All right, let's talk about calculating empirical and molecular formulas. Now, when we are dealing with empirical formulas, we first have to just understand the definition of them. Now, an empirical formula is the lowest whole number ratio of the elements in a compound. Okay, so let me go back. Yep, resume slideshow. There we go. Sorry about that. All right, so empirical formulas are the lowest whole number ratio of the elements in a compound. Now, what that means is, for example, if I had the actual compound of C2H8, that is not the lowest combination of those elements. So I would have to I could reduce those. Since both of them could be divided by 2, then that could actually become CH4. Now this would be my empirical formula. Now sometimes the empirical formula and what we call a molecular formula are the same. Here, this would be the molecular formula, and this would be the empirical formula. So sometimes they're different and sometimes they're the same, but you have to know the definition of these, okay? And you have to be able to recognize them within your multiple choice type questions. So if we have CH4, that's in its lowest format, but C2H8 is not. So CH4 would be our empirical formula, all right? So we're going to talk a little bit about how to calculate them. So I do have steps written here, and I think these are also in your notes, but I kind of really just want to talk about the poem, okay? So if we're given a 100-gram sample of the, we're going to assume that we have a 100-gram sample. So empirical formulas, okay? The poem to do this is you're always going to take the percent to mass, which means you're just going to change the percent sign to grams. And then you're going to do mass to moles, which means you're going to change that gram value into moles by using your molar mass. Then you're going to divide by the smallest amount of moles that you get when we're talking about all the elements in the compound. Everybody will get divided by the smallest amount. And then when you get those numbers, which we'll call mole ratios, you'll round them till they're whole numbers. If they're not whole numbers already, you'll round them so that they are. And then you'll use those numbers as your subscripts in your formulas. Okay, so percent to mass, mass to moles, divide by smallest, and round till whole. That's the poem in order to do an empirical formula. So let's try it. If we have a compound that is 79.8% carbon and 20.2% hydrogen, we want to find its empirical formula. Well, the poem says percent to mass. So we're going to change all these percent signs to just grams because we're going to assume now that we have a 100-gram sample of this. Okay, so if that's the case, we're going to go percent to mass and then mass to moles. So we're going to use our T-bars or train tracks and go ahead and do the molecular mass, the molar mass, and 1 mole. So we're going to go from grams to moles. All right, so percent to mass and mass to moles. So for carbon, we would change just that percent sign to a gram, and then we would divide by the molar mass of 12.01, and that would give us 6.64 moles of carbon. Okay, for hydrogen, we did the same thing, percent to mass and then mass to moles. So we would go percent sign to grams, and then we would divide by 1.01 grams. That would give us 20 moles of hydrogen. Now the poem says percent to mass, mass to moles. Divide by small. So the small number would be our 6.64 moles. So we're going to divide both of those by 6.64. So we're going to take the 6.64 and divide it by itself, which would give us 1. And then we're going to take the 20 and divide it by 6.64, which gives you like 3.01, yada, yada, yada. So that will round to just become 3. So since this is now going to be 1, we're going to say there's only going to be 1 carbon in the formula empirical formula. And since this will get rounded to 3, that will make 3 hydrogens in the formula. So our empirical formula would be CH3. Now, if I wanted to find the empirical formula for a compound made up of 26.7% of phosphorus, 12.1% of nitrogen, and 61.2% chlorine, my first thing to do would be take the percents and change them into mass. So percent to mass, so those percent signs would become grams. So I'd have 26.7 grams of phosphorus, and then I'd have 12.1 grams of nitrogen, and I'd have 61.2 grams of chlorine. Okay. Then I would end up wanting to change so I did percent to mass. Now I need to do mass to moles. So I would take my 1 mole of phosphorus, and I'd look up that on my periodic table, which that would be 30.97 grams. Then I would say for every 1 mole of nitrogen, it's 14.01 grams. And for every 1 mole of chlorine, it is 35.45 of chlorine. I'd then grab my calculator and I would do this division. So I've got 26.7 divided by 30.97, which would give me 0.862 moles of phosphorus. And then 12.1 divided by 14.01 would give me 0.864 moles of nitrogen, and 61.2 divided by 35.45 would give me 1.73 moles of chlorine. Okay, so my smallest one is my 0.862. So I would divide everybody by 0.862, which would give me 1, and then divide 0.862. Well, that's going to give me 0.864 divided by 0.862. That's going to give me 1.00, so roughly 1, rounded, and then divided by 0.862. So 1.73 divided by 0.862 would give me 2. Okay, 0.0 something. So those are rounded accordingly because it says round till whole. So if they're 0.0 something, we just round them. So that would make it to where for phosphorus, I would just have 1. For nitrogen, I would just have 1. And for chlorine, I should have 2. So my empirical formula would be PnCl2. All right. So again, if you can remember the poem, you could do these calculations. But primarily what you need to realize is that empirical formulas are the lowest whole number form of a compound. So it's the lowest whole number ratios of the elements in a compound. So that is your empirical formula. So really just knowing that definition is going to be beneficial to you. So let's talk a little bit about molecular formulas on the flip side of that. Now, molecular formulas are what we call the actual formulas. They're not always the lowest whole number ratio, but they might be. So they may be the same as the empirical formula, or they may be, like I said, a multiple of it. All right. So to find the multiple, you're going to take the molar mass of the compound, or I would say what of the final compound. I would also call that sometimes the molecular mass. So I like to say this sometimes more as the molecular mass because it's the mass of the molecular formula. and divide it by the empirical formula mass, which we'll call the EFM. Once you do that, you're going to have a ratio number there. That ratio number is what you multiply all of the subscripts in the empirical formula by in order to get the molecular formula. So let's do an example. We have a white powder and it's analyzed and found to have the empirical formula of P2O5. Okay, so the compound has a molar mass or molecular mass of 283.9 grams. So what is the compound's molecular formula? So we first have to find the molar mass of the empirical formula. So to do that, we would say that we have phosphorus and oxygen, and we have 2 and we have 5 times phosphorus is, again, we just looked that one up, it is 30.97. Yep. And then oxygen is 16. So then we go to our calculators and we go 30.97 times 2, which would give me 61.94 grams. And then we do 5 times 16, which is going to give me 80.00 grams. Then we're going to add those together and we get 4, and we get 141.94 grams per mole, okay, as our empirical formula mass. So once we do that, we can then take our molecular mass, which they gave us up here as 283.9 grams. We'll divide it by the 141.94 grams, and we'll come up with a value. So 283.9 divided by 141.94 gives me about 2. So that means that my whole formula, P2O5, has to be multiplied by 2. So when I do that and multiply all those subscripts by 2, it's now going to become P4 and O10. That's going to be my molecular formula. Remember, empirical formula is your lowest whole number ratio. Molecular formula would be those the multiple ratio, the actual ratio in the formula. Okay? I think I have this on here. Yep. Okay. Then we have a compound used as an additive for gasoline. And in order to do this one, we're going to first have to figure out the empirical formula, and then we're going to figure out the molecular formula. So first things first, we have to change percent to mass. So we're going to do 71.65 grams of chlorine. Then we're going to do 24.27 grams of carbon, and then we're going to go 4.07 grams of hydrogen. We're then going to change each of these to moles, so 1 mole, because it's percent to mass. Whoa, that is not what I wanted to happen. All right. And then chlorine, as we've looked up before, is 35.45. Okay. I don't know where. Click to restore writing. There we go. I don't know if I have these written. I do. Okay. So I don't know that I have these rounded correctly, but this should be 35.45 that we would divide that by. Then this one should be 12.01, and then this one is 1.01. So those are correct. So logistically, we're going to end up with those values of 2.02, 2.02, and 4.03. So we'll divide by the small, which means we'll divide each one of them by 2.02, which will then give us the ratios of 1, 1, and 2. Okay, so that means our empirical formula would be 1 chlorine, 1 carbon, and 2 hydrogens. Okay, you can write that in any order actually, all right? But it would be ClCH2. Now we have to find the mass of that compound. So we look up, we use 35.45 and we add 12.01 and then we add 2.02 because there's two hydrogens. So that gives us a mass of 49.5. Logistically, those numbers aren't rounded to two numbers after the decimal like we do, but that is about the number where we would come up with. And then we will take our molar mass, or what I call our molecular formula mass. I don't know if it's going to let me do it. It's being weird now. Yep, we'll take our 98.96, divide it by our 49.5, and that will give us a ratio of 2, which means we take our empirical formula and multiply them all by 2. So we have C2H4Cl2. All right. So this one would be our, okay, so this one would be our empirical formula. And this one would be our molecular formula, because notice it's not in its simplest whole number ratio. All right. Again, we can practice these, but it's primarily just making sure that you realize you'll do the same thing you would for an empirical formula. Find your ratios for your subscripts, and then you would find the mass of your empirical formula and take your your molecular mass and divide it by your empirical formula mass to find what ratio you should multiply everything by. Okay? All right. I believe that is all we have, and that is the end of the notes.